Hi, students. How are you today? So I'm helping with map testing. So you're going to kind of be on your own a little bit. I think somebody will be monitoring the meeting. I'm not sure about that, but it doesn't matter because you've got this. What we're going to do today is I've got a little surprise for you. I know you probably didn't do your homework last night. So guess what we are doing? We're going to do those 5 homework problems. So if you did them, this is your opportunity to check them. If you didn't do them, this is your opportunity to get really good at this. I do want you to work on your do now and your exit. So your do now will be a prompt about this solve approach to problem solving. Our objective will be to solve those inequality applications, systems of inequalities. Our essential question: what are some real world problems that can be solved with a system of inequalities, and how can I set up those problems? Remember, for participation credit, complete your do now and your exit in teams. Complete each of the problems. Please show me every step towards solution finding. However, I'm going to have you do the majority of your graphing in Desmos. This is not a lesson about how to calculate slope on a graph or use the y-intercept. This is a lesson about uh, drafting and solving these inequalities. And I want you to focus on that. And some of the numbers in some of these problems get pretty big, so the intervals could be a little tricky to work with. So I want you to focus on setting up the problem, putting the after you derive the two inequalities, I want you to focus on putting those into slope-intercept form, even though they're inequalities. And then we're going to go ahead and use Desmos a lot, and I encourage you to do that as well. But surprise, surprise, we're going to have a short quiz tomorrow, maybe just a couple of problems that are similar to these. So I want you to become an expert at today's lesson. So you know the drill here. I don't want to spend a lot of time talking about that. I've told you about your quiz. We will go back with this exit ticket, and this is going to be some helpful information for tomorrow. Please consider the pie contest. If you know that if you do the pie contest with fidelity, working hard, we can substitute one of your quizzes for your performance on the pie contest. So here's this solve approach to problem solving. I love this. I want you to read this carefully, and I want you to think about if this is an approach that could work at school, or do you think teachers and administrators would use this approach? And I want you to answer that question right here. But for now, I'm anxious to get on to these problems. We've been working pretty hard. Oh, let's continue on and let's really get this right. So we've got Emily. Emily wants to buy turquoise stones on her trip to New Mexico to give to at least 4 of her friends. The gift shop sells small stones for $4, large stones for $6. I hope Emily remembers her math teacher when she brings these beautiful turquoise stones back. But Emily's got no more than $30 to spend. So these are her parameters. These are the limitations of the problem. So we have to define our stones, okay? So we've got these small stones for $4, so we'll make that X. We've got these large stones for $6, that will be our Y. And she wants to buy them for at least 4 of her friends. So X plus Y must be greater than or equal to 4. Okay, let's take a careful look at this language as we do these problems. At least, greater than or equal to. Now, she's got no more than $30 to spend, so that's our less than or equal to. So how much are these stones? Well, $4 for the small ones plus $6 for the large ones can be no more than $30. Now let's put these into slope-intercept form. And in case of the first equation, y is greater than or equal to negative x plus 4. And in the case of the second inequality, y is less than or equal to negative 2/3 x plus 30. Okay, so we would graph these with the y-intercept of 30 and of 4 for this one, and a slope of -1 in the first case and -2/3 in this second case. So then we're asked to write two possible solutions. So let's go over to our Desmos. Now remember, if you were to graph this problem, you would have to think carefully about the intervals. So remember, the x-axis are the small stones. The y-axis is the large stones. Okay, that's the y-axis, the x-axis. You would have to think very carefully about what you want these, especially these y intervals, to be, because we've got some bigger numbers here, and they're going to get even bigger with some of these problems. So let's take a look at Desmos. Here's our x plus y is less than or equal to 4. Or I'm sorry, greater than or equal to 4. She wants to buy stones for at least 4 of her friends. And then here's our 4x plus 6y must be less than or equal to 30 because she can't spend any more than $30. So there's that inequality all by itself. And here we have this overlapping region right here. So anything that falls within this overlapping region is a solution to this problem. So what are two possible solutions? Well, if she bought 2 of the small, oh, let's not forget, we are only interested in whole number solutions, okay? We cannot buy a half of a stone. And we're only interested in quadrant 1 of the coordinate plane because this problem does not make sense with negative quadrants. So, okay, so if she bought 2 small stones, she could buy 3 large stones, and we could have the 0.23 could be a solution. And we could actually, oh, I don't have my keyboard attached to it, so maybe we could actually attach, yeah, I can do it this way. Parenthesis, so if she did 2 of the small stones, she could do, I think, 3 of the large stones. There we go. And there's the 0.23 right there. That would be a solution. How about if she wanted to get 5 small stones and she wanted to get 1 large stone? Is that within our solution area? And it definitely is. Let's take a look at those 2 points. There they are. So there's our solution area, and there's 2 possible solutions. So let's write that on our notes. 2 possible solutions would be 2 small and 3 large. Another possible solution would be 5 small and 1 large. Okay, let's move on to the second problem. And this problem is about earning money. We love these problems, right? They're real world problems, and they can, guidance like this can help us figure out our own finances. So suppose you can spend no more than 15 hours a week at your 2 jobs. Well, good for you for having 2 jobs. Way to go. And you probably cannot spend more than 15 hours a week because you're taking algebra and other hard classes at school that require your attention and your homework. But we've got mowing lawns, which pays $3 an hour, and babysitting, which pays $5 an hour. Now, you've also got this other parameter, this other requirement that you need to earn at least $60 a week. So maybe you're saving up for something, a nice gift for Mrs. Gold for her birthday, June 3rd. Maybe we should write that down, June 3rd, Mrs. Gold's birthday. So you need to start saving now for a really nice present, maybe some of those turquoise stones from Mexico. So let's write and graph a system of linear equalities. So we've got this language again, this no more language, no more than $15. So that's going to be less than or 15 hours, excuse me. That's our less than or equal to language. And you want to earn at least $60 a week. That's our greater than or equal to language. So X can be lawn mowing, and Y can be babysitting. So we can say X, lawn mowing plus babysitting, must be less than or equal to 15 hours a week. You don't want to work more than that, or it might compromise your schoolwork. But we want to earn at least $60. So lawn mowing at $3 an hour plus babysitting at $5 an hour should be greater than or equal to $60. So the next thing we want to do is put these in slope-intercept form. So let's go ahead. The first one, I think I'm going to have to use this side because I've already written over here, would be y is less than or equal to negative x plus 15. And the second inequality would be y is greater than or equal to negative 3/5 x plus 12. Now, how do we get the 12? Well, when we divided by 5, we moved 3x over, we divided by 5, 60 divided by 5 is 12. That's how we got the 12. We simplified the fractions. We keep in proper fractions, but we do simplify them as much as possible. We don't make them into mixed numbers. Okay, now we've got our two inequalities. So let's go to Desmos, but before we do, let's just kind of see what's going on here. The mowing is our x-axis because we've defined that as x, and the babysitting is our y-axis. So when you graph this, if you were to graph this by hand, you'd have to be pretty careful with these intervals. You know, we have x plus 15 here, negative x plus 15. So we have a y-intercept of 15 here, and we have a y-intercept of 12 here. So let's take a look at Desmos. We'll turn off the prior problem. And first we have that both the babysitting and the lawn mowing cannot be more than 15 hours a week. So again, we are only concerned with quadrant 1 here because 2, 3, and 4 would all contain negative integers. The only quadrant where both the x value and the y value are positive is quadrant 1. Now we've also got, you know, the amount of money we want to earn, which is at least $60. So on its own, this inequality with 3 times the number of hours we mow and 5 times the number of hours we babysit, everything here in this purple area is greater than 60. But because we want to work less than 15 hours, we have constrained our possibilities for earning money so that we can only be successful with our requirements in this small sliver of a triangle right here in quadrant 1. So the question also asks us, what are 2 possible solutions? Well, what if we were to, let's say we were to have 1 hour of mowing I can't seem to get my pop-up down there. But if let's say we have 1 hour of mowing and 13 hours of babysitting. So that would be 1 on the x-axis, 13, that would be right here. And that's fine. What about 4 hours of mowing? So again, let's look at our intervals. We always have to be careful with those. So 4 hours of mowing is this line here, and 10 hours of babysitting. And there it is. That is well within our parameters. Let's see if I can get the point to. Oh, it's hard to do it on the video. But you can see that the point 410 definitely falls within our solution area. So let's go back to our paper. So we said that 1 hour of mowing and 13 hours of babysitting would work. And we also said that 4 hours of mowing and 10 hours of babysitting. Now, unfortunately, you can't always control this. If you've mowed for 3 hours and the lawn is not done yet, you haven't finished mowing the lawn, you're not going to leave the job and say, nope, I decided I'm only going to work 3 hours at this because I'm babysitting for 10 hours or 11 hours. No, you can't do that. You have to do what's right for the person that you work for. But this will give you an idea of how to accept jobs, not take on too much work so that you can still get your schoolwork done. So let's move on to problem 3. A contractor has at most $42 to spend on nails for a budget. At most is going to be our less than or equal to. Finishing nails cost $45 a pound, so let's make that our X, finishing nails. And common nails, that will be our Y, cost $60 per pound. He would like to purchase at least 30 pounds of nails. So at least will be our greater than or equal to. So I'm going to put my X and Y axis on my coordinate plane. So X is going to be the finishing nails, and Y will be our common nails. And so the most he's got to spend is $42. So if the finished nails are 45 cents, that's 0.45x plus 60 cents for the common nails, 0.60y, must be less than or equal to 42. And he wants to have at least 30 pounds of nails. So that's the finishing nails plus the common nails must be at least greater than or equal to 30. Again, I'm going to put it in slope-intercept form. And let's change my color so we can do that. So the first inequality would be y is less than or equal to -3/4 x plus 70. And the second one would be y is greater than or equal to -x plus 30. Now, we've got some pretty big numbers here. So you either need to think about how you're going to plan out the intervals for your graph, or we'd have to reduce this somehow. And we really can't do that because it's as simplified as it can be. So we need to think carefully about this. So the x-axis are the finished nails. The y-axis are the common nails. And we're going to go ahead to Desmos just because this is getting so it would be almost impossible to graph on paper. So the finished nails and common nails can't cost more than $42. Look at these intervals. Look at the x-axis and y-axis when I made this inequality so we could see the whole thing. So each major block is 10, 20, 30, 40, 50, 60, and the same with the y-axis. Now, we said that x plus y must be greater than or equal to 30 because he wants at least 30 pounds of nails. So that's that inequality. Let's look at the overlap. So we have this nice big section of overlap where anything in that darker section would be a solution to the inequality. So we could have, let's say, 50 pounds of finishing nails and 20 pounds of common nails. We could have 10 pounds of finishing nails and 60 pounds of common nails, or any other combination in between would fit the parameters that this person has set up to do their shopping. So let's say we could say again, there are many other right answers for this section sub 1 and sub 2, but we could have 50 pounds of finishing nails, combined with 20 pounds of common nails. We could have 10 pounds of finishing nails. Combined with 60 pounds of common nails. And there are many other combinations that would be correct. So let's go on to the next problem. Okay, local theater. My friend is opening a theater. She's been working on it for 5 years and it'll be open in April. So local theater has a maximum capacity of 1,000 people. So maximum capacity includes 1,000. Could 1,000 people be there? Yes. So that's going to be less than or equal to. For their latest production, adult tickets cost $25 and youth tickets cost $12.50. The theater must make at least, okay, so greater than or equal to 15,000 for the show to go on. So let's tease this apart. We need to define our X and Y values. So let's let X equal the youth tickets and Y will equal the, let's see, adult 25. I'm going to change that. I'm going to make adult tickets the X. You can do it either way, but I practiced it this other way. Youth tickets will be the $12.50. Okay, so she can sell no more than 1,000 tickets because she only has 1,000 seats. So X plus Y must be less than or equal to 1,000 because that's the maximum capacity. Now, the youth tickets and the adult tickets must make her at least 15,000 or she cannot cover her expenses. So we've got the adult tickets for $25 plus the youth tickets for $12.50. I can put 12.5 there. And that must be greater than or equal to 15,000. So let's get those in slope-intercept form. The first problem would be y is less than or equal to negative x plus 1,000. The second problem would be y is greater than or equal to negative 2x plus 1,200. And I'll tell you how I got that. Okay, so we have to move x over to the other side, and then we divide everything by 12.5. And 25 divided by 12.5 is negative 12.5 is negative 2. 15,000 divided by negative 12.5, I'm sorry, by positive 12.5 is 1,200. So let's take a look at the graph. And remember, this is, unless you had really huge intervals here, this would be very difficult to graph. But let's remember the adults are the x-axis and the youth are the y-axis. And let's go to Desmos and check it out. So we have to sell at least, well, we can't sell any more than 1,000 tickets, okay? And here's the first quadrant of the coordinate plane. And no matter what combination of adult or child tickets we sell, we can't sell more than 1,000. So we can sell 200 adults and 400 youth, or we can sell 600 adults and 200 youth. As long as that is 1,000 or less, we're okay. But then we also have to make $15,000 for the show to go on. So we have to sell more than this number here. Well, you can even see on this line, you see this 1,200? That's not going to be part of the solution set because that's more people than there are seats in the theater. So let's put it all together and look at the solution set. And you can see that 1,200 doesn't make it into the solution set because we can't sell more than 1,000 tickets total. So here's our sliver of a solution set right here. And we see some solutions. If we sold 700 adult tickets, we could sell 100 youth tickets, or 200 youth tickets would be fine. If we sell 400 adult tickets, we better sell at least 400 youth tickets, or we could sell 500 youth tickets. Got to keep within that shaded area. So one combination would be 700 adult tickets combined with 100 youth. Or we could sell 400 adult tickets with, let's say, 500 youth. What we could not do is we cannot sell 200 youth tickets and only 200 adult tickets and only 400 youth tickets. That would not work. That would be right there. So we have to stay within those parameters. And then let's look at our final problem of today. This is about the zookeeper. He wants to make a fence, and he wants it to be rectangular. So he wants to make a fence sort of like that, okay? And that's going to be for his goats. Well, it's important that we know that it's rectangular. We don't need to know it's for goats, but they wanted to tell us that. The length of the habitat should be at least 80 feet. So it's going to have to be greater than or equal to 80 feet. The perimeter, and the perimeter is around the outside, should be no more than 300 feet. So it can be 300 feet, excuse me, and it could be less than 300 feet, but no more, less than or equal to. Maybe he only has 300 feet of fencing material to use, but he wants at least 80 feet on the long side of the fence. So how are we going to lay this out? Well, all we're told about either singular side of the fence is that he wants the length to be at least 80. Nothing is said about the width. So if we define x as the length and y is as the width, then we would say x must be greater than or equal to 80. And then for our second inequality, remember we have two lengths and two widths on every rectangle. So 2 times the length plus 2 times the width must be less than or equal to 300 because he doesn't want the perimeter any larger than that. Maybe it's the amount of fencing he has, maybe it's a zoning issue, who knows. But we put that second inequality, slope-intercept form, we have y is less than or equal to negative x plus 150. Now, how do we get the 150? We moved 2y, that should be a y, sorry. I made a W instead of Y, so I was thinking of width. We moved the 2x over to the other side and we divided everything by 2 from the coefficient in front of the y, and that made this negative x plus 150. So remember, the x-axis is the length and the y-axis is the width. So let's take a look at this graph. Again, big numbers, really hard to hand graph. We'll use Desmos. So here's our length must be at least 80 feet. And here is our length and width together must be less than 300. So what's it going to be when we put them together? Well, here it is. We have this small sliver, or small triangle, not a sliver actually, that fits the parameters of the problem. Now, do you notice how the shape of that triangle changes according to how I manipulate Desmos. What's important to look at are the interval numbers, okay? We'll get only interested in uh, quadrant 1 of the coordinate plane. So he could have a 90-foot width, 90-foot length, excuse me, with a, let's see, 10, 20-foot width right there. He could have a 110-foot length with a 30-foot width right there, 120-foot length with a 20-foot width right there. So anything within that area, that triangle right here, anything in there is a possible solution. So possible solutions could be 90 feet, and that would be the length, by 20 feet for the width. Could be 110-foot length by 30-foot width. Lots of solutions there. So I want to go back to the exit. When solving and graphing linear inequality applications, keep in mind, okay, for many problems, there's one point, or I should say for many applications, only the first quadrant is relevant. Okay, another thing to keep in mind, for many applications, only whole numbers are relevant. If you're talking about how many people can fit somewhere, you're not going to have a half a person. So only positive whole numbers, I should say, for many of them. And we also want to keep in mind, define your X and Y, and to watch the language carefully so that you know whether to use greater than or equal to, or just greater than without the equal to, the same thing with less than. And then finally, be mindful of your intervals. And that's on the X or Y axis. Because it might be appropriate to have your intervals be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. Or maybe you need to count by 5s or 10s or 20s, or even by 100s, depending on the kind of numbers you're dealing with in the problem. So we're going to have a short quiz tomorrow with just a couple of these problems. Make sure you practice these, go over these again at home. And with practice, as always, you'll be great.